This video is about equivalent forms of rational expressions and applications. So we're going to take a look at how to rewrite fractions in some equivalent forms when you have a negative fraction. Remember, you can write the negative sign out in front of the fraction, or you can write the negative sign up in the numerator, and you can also write it down in the denominator. So that's what we're going to be looking at today for rational expression. Example has a negative sign out in front of the fraction. The numerator is x minus 2 and the denominator is x plus 5. So we're going to rewrite that with a negative sign up in the numerator. And you have to remember to put that numerator in parentheses. And so we'll have the negative sign out in front, and then that's times the quantity x minus 2. And so the reason it's so important to put it in parentheses is because we need to distribute the negative sign. So in the numerator we'll end up with negative x plus 2, and in the denominator x plus 5. The other way that we could write this fraction would be to write the negative sign down in the denominator. So that would be x minus 2 in the numerator, and then a negative sign, and then the parentheses and x plus 5 in the denominator. Again, the importance of putting those parentheses is so that you remember to distribute the negative sign. So this would be x minus 2 over negative x minus 5. Our next example, the negative sign is out front, and in the numerator it's y plus 3, and in the denominator y minus 11. So first we're going to write the negative sign up in the numerator. So it would be the negative sign and then inside parentheses y plus 3, and in the denominator y minus 11. Distributing the negative sign would give us negative y minus 3, and in the denominator y minus 11. Next we're going to write the negative sign down in the denominator. So we would have the y plus 3 in the numerator, and our negative sign, and in parentheses y minus 11. So we have y plus 3 in the numerator, and then distributing the negative sign in the denominator gives us negative y plus 11. Next we have an application problem. A company's cost per book for printing X books is given by the function c of x equals 0.8x plus 5,000 over x. Find the company's cost of printing A, 300 books and B, 3,000 books. So what we want to do is replace the x in our function with 300. So we're going to find c of 300. And that will be 0.8 times 300 plus 5,000 divided by 300. So we can compute that on our calculator. So it will be 0.8 times 300. That gives us 240, and then we also need to add the 5,000 in the numerator, so plus 5,000. And that gives us 5,240, and then divide by 300. And so our final answer is 17.46 with the 6 repeating, but this is money, so we're just going to round to 2 decimal places. So that would be 17.47. So then write a sentence to answer your question. Whenever you have a word problem, you should always answer with a sentence. So the company's cost per book is $17.47 when they are printing 300 books. We want to do the same thing when they're printing 3,000 books. So we want to find c of 3,000, and that will be 0.8 times 3,000 plus 5,000, and then divide that by 3,000. So again, we can do that on our calculators. 0.8 times 3,000, and that gives us 2,400, and then add to that 5,000, and that gives us 7,400, and then divide that by 3,000. So we get 2.4, and then again the 6 repeats, so we want to round that to 2 decimal places, so that would be 2.47. So this time the company's cost per book is $2.47 when they print 3,000 books. So notice when they print more books, the cost per book decreases, and that's because of the fixed costs. So it doesn't matter how many books they print, they still have to pay rent, and they still have to pay to have the lights on and for electricity and all of those things that are fixed compared to how many books you buy or how many books they print. So that's why the cost per book decreases as they print more books. One more application problem. Calculating body mass index is a way to gauge whether a person should lose weight. Doctors recommend that body mass index values fall between 18.5 and 25. The formula for body mass index B is B equals 703W over H squared, where W is weight in pounds and H is height in inches. Should a 148-pound person who is 5 feet 6 inches tall lose weight? So first notice that the height here is in inches, and we have their height in feet and inches, so we need to convert these feet to inches. So we have 5 feet, and we want to convert that to inches. And so we want to multiply by our conversion factor, so we want the inches on the top, and we want the feet on the bottom, because you always want the units you're going into to be on the top, and there are 12 inches in 1 foot, and so we're going to multiply the 5 by 12, and so that's 60 inches. And so this person is 66 inches tall. Now we can plug into our formula B. It's 703 times W, and their weight in pounds was 148. And then divide by their height, 66 squared, actually it is. So again, we can use our calculators to compute this. So 703 times 148. And then we want to take that and divide it by 66 squared. So we end up getting 23.885. Is their body mass index, and if it's between 18.5 and 25, that's the recommendation. And so our body mass index falls in between there, and so this person does not need to lose weight. And that finishes up our lecture on equivalent forms and applications. Let me know if you have any questions.